Hi, I'm Ms. Cho, and in this video, we'll add and subtract rational expressions with like denominators. Rational expressions are fractions with one polynomial divided by another. We can add rational expressions that have the same denominator like we add fractions. So for example, if I wanted to add 3/8 plus 1/8, I would keep my denominator and then add my numerators. And then I would have 4/8, which then I could simplify as 4/1 times over 4/2. I can cancel out my common factors of 4, and I'm left with 1/2 in simplest form. The same process goes with rational expressions. If I have the same denominator, I can keep my denominator, and then I'll just add the polynomials on top. Then I can check and see if they have any common factors to simplify. Let's take a look at an example. In our first example, we're asked to find the sum and domain of x plus 2 over x squared minus 2x plus 3x minus 10 over x squared minus 2x. We're going to follow 4 steps. First, we change subtraction problems to addition. Then we find the domain using our undefined values. Third, we add the numerators and keep the common denominator. And fourth, we simplify by checking for common factors and canceling those that appear in both the numerator and the denominator. Since this is an addition problem, we can skip ahead to step 2, and we're going to find the domain using our undefined values. Our denominator is x squared minus 2x, and I want to know what makes that 0. So I'm going to set that equal to 0. I can factor out an x, and then I have x minus 2. That gives me x equals 0 and x equals 2 as values that when I plug in will make this expression 0. From there, I will add my numerators and keep the common denominator. So I'm actually going to keep my denominator in factored form, so it's easier to deal with. And I combine my numerators x plus 2 plus 3x minus 10, and then combine like terms. X and 3x make 4x, 2 and the negative 10 give me negative 8, and then I have x over x minus 2. From here, I notice that my numerator has a greatest common factor of 4, so I'm going to factor the 4 out, and I have x minus 2 left. I have x over x minus 2. My common factor is an x minus 2, so this means my simplified form is 4 over x, where my domain is all x except x equals 0 and 2, which we talked about right here in this step. You might also see this as an x is not equal to 0 or 2. Let's try a second example. We're asked to find this difference and domain of 3x plus 2 over x minus 1 squared minus x plus 4 over x minus 1 squared. Since this is a subtraction problem, we do need to change this to an addition problem by adding the negative. However, I am adding a negative of the whole thing, so I'm going to actually put a negative 1 here to remind myself that I need to distribute this. So I'm going to actually just make myself a note that this is minus x minus 4. From there, I'm going to find my domain using my undefined values. So my denominator is x minus 1 squared, or x minus 1 times x minus 1. When I set that equal to 0, I know that x must equal 1. And x equals 1, but that's just the same thing. So this means that when I plug in a 1 here, it makes my denominator 0 or my expression undefined. Now I am going to add my numerators and keep the common denominator. So I'm actually going to keep this factored of x minus 1 as my denominator. And in my numerator, I have 3x plus 2. And then my distributed expression for the second one. So this is minus x minus 4. From here, I am going to combine my like terms. So 3x minus an x gives me 2x, a 2 and a negative 4 gives me a minus 2, and I have x minus 1 times x minus 1. I notice that my numerator has the greatest common factor of 2, so if I factor that out, I have x minus 1, I have x minus 1 in the denominator, and I have a common factor of x minus 1, which means that my simplified form is 2 divided by x minus 1, where my domain is all x except x equals 1, or x is not equal to 1. Let's summarize. When we add and subtract rational expressions with like denominators, we change subtraction problems to addition. If your second numerator has multiple terms, you must distribute the -1 among all the terms. Secondly, we find the domain using our undefined values. We set our denominator equal to 0 and solve for x. Third, we add the numerators and keep the denominator. And fourth, we simplify if needing by canceling common factors.